Ohm's law. Have you ever used a light with a dimmer? Take a look at the one in this room. When the dimmer switch of this light is turned towards the right, the light glows brighter, and when the dimmer switch is turned towards the left, the intensity of the light is reduced. Isn't it delightful? How does this happen? What is the principle behind this phenomenon of increasing and decreasing intensity of light? Let's find out. The switch used for the dimmer light is a rheostat dimmer switch. It is an example of the Ohm's law application. The movement of the dimmer switch changes the voltage across the bulb and alters the electrical current. This affects the flow of current supply to the bulb, making it glow bright or dim. Did you notice that there is a relationship among the flow of the current, the voltage, and the resistance? This relationship was discovered and proposed by the German physicist Georg Simon Ohm in 1827. The Ohm's law states that the electric current I flowing through a conductor is directly proportional to the voltage V, also called as the potential difference, across the ends of the conductor, and it is inversely proportional to the resistance R of the conductor, provided the temperature of the conductor is constant. This can be expressed as the voltage V is directly proportional to the current I, or V divided by I equals to constant. This constant is called as R, or resistance of the conductor. We can also say that V equals to I into R, or R equals to V divided by I. This mathematical expression of the Ohm's law can be well presented through the Ohm's law triangle. The Ohm's law triangle is useful to find the unknown value of V, I, or R if the values for the any two variables are given. Let's see how. Cover the unknown variable in the Ohm's law triangle and perform the calculation of the remaining two variables. For example, to find the value of V, we will cover V and we get the equation V is equal to I into R. When we cover I, we get I is equal to V by R. When R is covered, we get R is equal to V by I. Thus, we get three important equations using the Ohm's law triangle. The Ohm's law gives us two important relationships. V is directly proportional to I, and I is inversely proportional to R. We will understand these relationships by comparing the flow of water in pipe system with the flow of electric current in a circuit. In a pipe system, the pump applies pressure that makes the water flow. In the electrical circuit, it is the potential difference or voltage that pushes the charges and make them flow in a circuit. The turbines in the pipe system resist the water flow, just like the resistor in the circuit. Now, let us first study how pressure or voltage is directly proportional to the current. In the pipe system, the pump is set at medium pressure. Observe the rate of flow of water. When the pump is set as low, the pressure reduces and the rate of flow of water decreases. When the pump is set as high, the pressure increases and the rate of flow of water also increases. This shows us that pressure is directly proportional to the rate of flow of water in the pipe system. Now, let us see the similar phenomenon in the electrical circuit. In a circuit, the voltage across the conductor causes pressure on the charges and pushes them to flow in the circuit. This flow of charges is what we call as a flow of current in the circuit. When the voltage is increased, it causes more pressure and the rate of flow of charges in the circuit increases. It means the current flowing towards the bulb in the circuit increases, making the bulb glow brighter. When the voltage is reduced, the flow of the current also decreases, making the bulb glow dim. This demonstrates that voltage is directly proportional to the flow of the current. Now we will understand how the electric current in a conductor is inversely proportional to the resistance using the same analogy of the pipe system. For this, we will fix 2 or more turbines of the same size in the pipe system, keeping the pressure of the pump constant. You will see that addition of a turbine decreases the rate of the flow of water. Now, let us remove 3 turbines, keeping the pressure of the pump constant, and observe. We have reduced the resistance and we can see that the rate of flow of water is increased. This demonstrates that the resistance is inversely proportional to the rate of flow. Now, in the electrical circuit, we will increase the resistance, keeping the voltage constant. We see that increase in resistance decreases the rate of flow of the charges. That is, the flow of the current is decreased, making the bulb glow dim. Again, if we decrease the resistance, the rate of flow of current increases and the bulb glows brighter. This shows that electric current is inversely proportional to the resistance. Let us see the graphical representation of the expression V is directly proportional to I. We have a circuit of a bulb. We will plot a graph of the readings for the current I read on the ammeter and voltage V shown by the voltmeter in the circuit. When a single cell is connected, the flow of current is 0.1 ampere and voltage is 0.4 volts. The ratio of V by I is 4. Now we will increase the current by adding cells one by one and observe the changes in the readings of the current I and voltage V. The ratio of V and I will be plotted on the graph. The graph plotted here results in a straight line. This indicates that when the current increases, the voltage also increases linearly. In this session, we have learned the Ohm's law. We also learned about the Ohm's law triangle used to derive the formula V equals to I into R. I is equal to V by R and R is equal to V by I. The principle stated in the Ohm's law has a great importance in the field of electricity as it is widely applied in several electrical appliances such as torch, mixer and the dimmer switches of the lights.